Good evening, everybody. Okay, and it's time to math out. Okay, we're going to do one question and one question only, and I think this one's a good one because it really does cover almost absolutely everything we need to know for radicals, specifically radical equations when we're trying to solve for x. So here we have it across the top, and what I would invite you to do right now is to pause the video and try to answer this for yourself, and then come back and see if you got it right when you go through it with me. That way you can see where you went wrong. This will be really helpful. So I recommend right now, pause. Okay, pausing. Okay, so now you should be back. Okay, so here we go. We're going to try to answer this question. All right, so first, what is the step one? It is finding the restrictions. So here we go. We're going to do our restrictions. And fairly straightforward here. So let's try it out. We've got a definite 4x plus 10 must be greater than or equal to 0. And we have a 2x plus 10 must be greater than or equal to 0. So we have two possible ones. Usually two don't work out. One is going to dominate, or in the case of the quiz, a whole bunch of them contribute to the same thing. So let's look at the first one, 4x plus 10. I'm going to move the 10 over and divide by 4, so I'm going to be left with an x is greater than or equal to a negative 10 over 4, which is really saying x is greater than or equal to a negative, let's reduce that, 5 over 2. 5 over 2, which is basically 2.5. If you made that into decimal form, you'd find that's what it gives you. 2x plus 10 is greater than or equal to 0. I'm going to be given an x is greater than or equal to a negative 10 over 2. Oh, this works out really nicely. We get an x is greater than or equal to a negative 5. Okay, so quickly I grab a number line. Here's my number line. Better move this guy down a bit. I'm not going to be able to fit everything in there. Okay, down you go. All right. Let's take a look. Okay, so here's 0. Here's 1. But everything's in the negative, so actually really 1 is at negative 2.5. That's the negative 5 over 2. And 1 is at the negative 5. And 1 looks like this. It's got to be greater than or equal to. And this one's greater than or equal to. And I have to say, this number line really works well, because where you're looking is where both of the statements are true. And it happens basically where you have both lines in the same spot. And this only takes place from here over. There's where everything is true. So for this case, this is going to be my real restriction that I'm looking for. Any answer I get must be bigger than or equal to negative 2.5 or 5 over 2. So with that, I am now able to continue. And I have to solve this problem. Okay, so first things, let's look at that equation. What do I have to do? And I'm going to take my restrictions. I'm going to move them way over here. Just going to take them out of the way. Over here. Stay over there in the corner. What's the rule? The rule is separate them radicals. Okay, so what I'm going to do is I'm immediately going to do that right off the bat. Hold on just 1 second now. Made a little mistake. Here we go. Whoops. I'm pressing all the wrong buttons. There we go. Okay, so I'm going to be left with a 4x plus 10. And then on the other side, I'm going to move this guy over. And that'll leave me with a positive, it's nice, 2x plus 10. Plus 2. So after that, it's fairly obvious that what I'm going to do is I'm going to take these and I'm going to square them. And it is clear that the left side is going to be pretty easy. All that does is it removes the square root, and I'm left with a 4x plus 10. But on the other side, things are a little more complicated, because really what I'm saying is that it's this whole expression multiplied by itself. I'm dealing with a binomial. So that's no problem. We know what to do with that. We've done that plenty of times with quadratics, so there's nothing crazy about it, but I know that this is not going to be a simple solution for me. So let's keep going. I'm going to still have the 4x plus 10, and I'm going to end up with what? Well, these first two guys are going to multiply together, and that's going to give me my happy 2x plus 10. Cool. And then I'm going to get a plus 2 root of 2x plus 10. That's these two guys. And also another one, plus 2 root 2x plus 10. So I'm going to get two of them. And then the 2's are going to multiply together, and I'm going to get a 4. Okay, so far so good. So what am I going to do? I am going to separate everything away from what's left of the radical. There's still a radical there, so I'm not sure what's going to happen yet, but let's see. I'm going to take the 2x, I'm going to bring it, let me see, this is what I'm going to do. I'm going to bring the 2x over, I'm going to bring it over to that guy, and I'm going to bring the 10 over, and I'm going to bring the 4 over. That's what I'm going to do. And then I'm going to leave these guys, I'm going to combine these guys together and see what happens there. So hopefully this is what you did. So I'm going to be left with a 2x, and this is a 10 minus a 10 minus a 4. So what's that going to give me? A 10 minus 10 minus a 4, that'll give me a minus 2x minus 4. And then that will be equal to 4 root 2x plus 10. Okay, so the bottom line here is that I'm left to have to square this again because I still got a radical, so I got to square it again, and hopefully that's going to take care of it. So let's look at this. What's this going to look like? I'm going to get a 2x minus 4 multiplied by itself. So once again, another binomial. And that's equal to this square. Now this square, that's interesting. What's going to happen here? Well, the outside number is going to square, so 4 times 4 is 16. And the inside, the radical itself will square, so that'll be 2x plus 10. Now notice I got brackets around that because I don't want to make the mistake of not realizing that it's 4 times this. So it's 16 now times the square of this, which is now the 2x plus 10. So I'm going to do a little multiplication there, and I don't want to make that mistake. You might have found you did that. So, well, you'll know, you won't tell me. Okay, so here we go. 2x minus 4 times 2x minus 4. I'm going to get a 4x squared. I'm going to get a minus, let me see, a minus 8x and another minus 8x. That's going to be leaving me with what? That's going to be a minus 16x. And then a minus, nope, a plus 16. And that will equal 16 times 2x. What's that going to be? That's going to be 2 times 16. That's 32x. And then plus 160. All right, I got to work this out. What do I got? Okay, so I got a 32 and a 16. What is that? Okay, wait a minute. I got to do the 4x squared. 4x squared. This comes over and becomes a negative. So now I'm going to have a minus 48x. And then the 160 is going to come over to the other side, and that's a minus 160 now. So it's minus 144. Now I brought it all over to the other side because actually I didn't actually say it, but I recognize this. This is a quadratic, and all I got are all the parts of the quadratic, so I know what I'm leading myself towards. It's going to be putting everything on one side, making it equal to 0, and then solving for the roots. So that's my next step here. So the question is can I take anything out of this? Can I reduce this in some sort of way? Well, yeah, I can take a 4 out of here, can't I? So I could take a 4 out, and all the terms, and I'll be left with x squared minus 4 times 12 gives me 48. And how many times do I get? 36 actually. Minus 36 equals 0. So now I've got kind of a much easier thing to deal with here. Now what number, I guess, can I use that's going to help me out here? I'm not sure yet. So actually I have no idea. So what I'm going to do is I'm going to use the trusty quadratic formula, and I'm going to solve for this thing right here. I can completely ignore the 4 now. I've taken it out, and really I'm trying to solve for this. The 4 just simply multiplies the entire answer by 4, and I'll end up dividing by 4 when I get my answer if I kept it in. So I'm not even going to bring it in. I'm just going to solve for this guy here. So what do I got? I got 12, that's my negative b, plus or minus the root of, and you guys know all this stuff anyway. You guys got this clear. It's going to be negative 12 squared, that's 144, minus 4 times 1, I'm not going to say that, times negative 36. And it's all divided by 2 times a, so that's just multiplied by 2. And that leaves me with 12 divided by 2, that's 6, plus or minus now. What's all this going to give me? So this is kind of freaky actually, because the answer here is 144, and the negatives become a positive, so I get a 140 plus a 144. So I have two 144s really in there is what I'm saying. Oh, you gotta remember that's 6, I've already divided the 2, so now I'm only looking at the 2 divided out here. I gotta find some space for that, so I'm gonna come up here, I'm gonna go right here, and keep answering this question. So I've got a 6 plus or minus the root of 288 divided by 2. Now since I know that 144 is 12 times 12, and I've got 2 of them, another way of looking at 288, if I was just trying to find out what I could take out of this radical, is that if this is 2 times 12 times 12, then I can take out those 12s and be left with a 2. I mean, that's pretty neat. So let me do that. That'll be 6 plus or minus 12 divided by 2. Whoops, not 12 divided by 6. 12 divided by 2 root 2. And 12 divided by 2, well, I don't even, let me just solve that. 12 divided by 2 is 6. Alright, that's where the divided by 2 comes in. I take the 12 out, I divide it by 2, I get 6. So now I've got 6 plus or minus 6 root 2. So the question is, what are those numbers exactly? This would be your answer. This would be your x is equal to, now are we done? No, we're not done. We have to see what the possible answers are. So let's just see what they look like in decimal form, just to give us a better idea of whether or not they fall within the realms of x being greater than or equal to negative 2.5, because we don't want a mistake there. So first we check that. So you might have pulled out your calculators and figured it out. What you've gotten would be 2 answers. 14.48, well above negative 2.5, but also a negative 2.48, very close to negative 2.5. I think it gets in by the skin of the teeth. I'd probably say, okay, they're both good so far, but we haven't actually checked it. We haven't actually checked them. Now, what you're wanting to do when you're checking, and I assume you already know how to do this, but let's remember that after all this work, we still haven't actually checked the answer. And what we're trying to find is whether if we plug in those 2 values, whether they give us the answer we're looking for. So whether if we plug in 14.48 into our x's, do we end up with an answer that equals 2? So we got to check. We got to go through it. We got to find out, and that's the end of our thing. So let's try it out. All right. So have we checked? Oops. Have we checked? So we plug it in. Root of 4 times 14.48. Whoa. Plus 10. And here I'm using the decimal because as long as I get close to 2, I'm gonna assume I'm right. I don't have to be super exact here. I'm checking. And if it's the wrong one, it's going to be pretty far off. I'm going to be able to tell. So 14.48 plus 10, whoops. And does this equal, whoops, barely enough room. Does it equal 2? I don't know. Let's find out. So 4 times 14.8 plus 10, I end up with, let me see, 67.92. And then here I'm going to find out what is the root of 38.96. And that equals 2. So what do I get? Well, if I square root that, I get 8.24. And that should be subtracting, what do I get here? Square root of 38.96 is 6.24. That's actually equal to 2. What do you know? So 2, hooray. So checked and well and good. Now, next one, check the next value. That's the negative 2.48. Gotta be a little careful with that negative, but it should be all right. 2 times negative 2.48. plus 10. Whoops,